Hey everybody, this is Larry. This is day 15 of the April Daily Challenge. Hit the like button, the subscribe button, join me in Discord. Let me know what you think about today's poem. And yeah, and looks like we have the weekly poem as well, so definitely check that out. And we're going to start today with a hard poem, so hopefully not too hard, because I do want to get some sleep. But before we start today, I did a little bit of squats. I think I'm kind of recalibrating my stance to be a little bit, hopefully, less injury prone. We'll see. So just kind of working my way up. But I'm just so tired. I've been working out too much maybe and not sleeping enough. But I do have a little bit of a mini announcement. It's not a serious announcement, or at least it's not a critical important announcement. But I am going to be in Europe at the end of the month in the Baltics. So if you are in the Baltic area, let me know. I'm talking about Lithuania, Latvia, and Estonia. So come to Discord. Let me know if you're from in those countries. Maybe we'll get food or something. I don't know. I try to do that once in a while. Yeah. Also, if you have recommendations in general. I mean, my schedule I think is pretty tight, but you know, if you have Rex, always happy to hear. So yeah, let me know. Anyway, let's take a look at today's poem. We have 2179. Count good triplets in an array. Yeah, let's go. Let me know. Okay, so you have good triplets, three distinct values in increasing order nums 1 and nums 2. In other words, if we consider num 1 as the value, okay, a good triplet will be a set x, y, and z where is less than, so x, y, and z are indexes, right? In which x, y, and z, and wait. All right, let's double check. I feel like maybe I understand it, but yeah. Okay, so these are the triplets in which there are 4 such triplets such that, oh yeah, okay, they're just 4 unique triplets, right? Okay, fine. 201, 203, okay, fine. Right? One of those triplets does 0, 1, 3 satisfied with the XYZ. Okay. Because it's going to be 203. Oh, no, it's 0, 1, 3 and 1, 2, 3. Right? Okay. I see, and so we count 1. Here, the 4 triplets are 4, 0. Huh? I thought this has to be increasing. I'm confused a little bit. 4, 0. This seems like today I am at least trying to figure out how to read, not even talking about a poem. But why? Okay, what is this increasing? Let me reread this. Sorry, friends. Today is a reading day. Okay, by position. What does that mean? 3 distinct values. Okay, so 4, 0, and 3 is going from left to right, increasing, and 4, 0, 3 is also increasing. So basically, okay, right? Is that right? Is that the right interpretation? I guess so. Okay, maybe that's the, okay, so they don't have to look up the same index. It's not lining up the same index. It's just the number of things. Okay. I think the first thing you have to realize is that n is 10 to the 5th. So you cannot do some n cubed things. I mean, I didn't really expect to, because this is a hard problem. So that would be, not a very hard problem. My first idea would be some sort of dynamic programming, but I don't know that that's right. Let's think of a, okay, n cube is very naive, but let's think of a naive-ish algorithm that's slightly less naive, right? So for example, maybe we have something like this, right? Let's put it here. Let's say we have something like this. Here maybe I'm thinking of like, okay, let's say I'm going through 0, right? And at 0, I'm counting out all the lefts and the right, and then it's almost like a set intersection, right? Because 0, we have 4 on the left side and then 3 on the right side, and there's some like degree of freedom thing, which in this case, yeah, there's 1 on one side, so then it's just 1. So that means that there's also the 2. Whoops. Yeah, so then here we're trying to figure out the middle number, right? And then the set intersection on the left, and on the right and on the right. The problem is that, of course, if you do it in a naive way, this is just going to, if you like do a set merge or something, it's going to be O of n, and that's going to be n squared at best. Maybe worse, but yeah. Which is actually, n squared, we already went from n cubed to n squared, so I guess we're pretty good. But can we do better? And we have to do better to solve this, right? Is that this is tough, right? Because you can't really, because an idea that I would maybe think about is just like a slide, not a sliding window, a scan line, right? A sweep line. So here maybe we go like to the right, right? But again, that's, well, not easy to do because this goes to the right and this goes to the left, for example, right? So then how would you, how would you think about this? The fact that there is a permutation may be interesting because, I don't know if it is, but it may be, because it means that if a number is not on one side, then it has to be on the other, right? So you know the set of numbers. But yeah, for example, for 1, you have 4 on the left side and 3 and 2 as a set intersection on the right side. Okay. I mean, I think my initial intuition would be that we take one of the arrays and then sweep and then try to pre-process the other array to kind of answer these queries. But I don't have any immediate like how-to about that, right? Because for example, we just go 4. Okay, 4. We have all these numbers to the right side, which we can easily process, right? So then now we have to find the 4 in here. But then now we have to figure out, okay, well, what numbers intersect here, right? I mean, of course, for 4, it doesn't matter because there's no numbers on the left side, so it wouldn't even out anyway. But how would you go, okay, well, there are actually 4 numbers to the right side, right? I think one idea that I'm playing around with my head, and honestly, I do not know how to do this off my head, so this is a very live portion. One thing that I'm thinking of is, and I don't know if this helps, but some sort of renumbering. And the reason why we renumber is because then now, because the label that they give you don't matter, right? So you can renumber it however you want. And the reason why you renumber then is that you don't have, this sweep line then becomes implicit, right? And what I mean by that is that on the left side, you have 0, 1. Let's just say you renumber it in the natural way of just from 0 to 1 to 4. And then now this means that 4 maps to 0, 0 maps to 1. And that means that we remap the second array into the new one, which may be in this case, let's see, right? So this will be 0, 1 maps to 2, 0 maps to 1, 3 maps to 3, but the 2 maps to 4 and the 3 maps to 3, right? So now you have these 2 arrays, right? So you have this one and this one now to kind of try to figure out the answer to. But except for now, when you go from left to right, you don't need to, from left to right, you don't need to know anymore what is the thing on here, right? You don't need to know what's on the left, what's on the right, because that's implicit. Because let's say you had the number 2 in the middle. You had number 2, you know that all the smaller numbers are to the left and all the biggest numbers to the right. That means that here now, or you could do it the other way, actually, maybe. I don't even know which way is a little bit cleaner, but I don't, maybe it doesn't matter, maybe it does, but I'm just thinking like, okay, that means that here we find the 2, and then we find out how many numbers are bigger than it afterwards, and how many numbers are smaller than it before, right? Or maybe you could even go, order it here, where you go, okay, well, here's the number 1. Well, number 1, we already know all the numbers smaller and all the numbers that are, numbers that are to the left and numbers to the right, and all the numbers to the left, well, you know that, on here, you don't have to do the query, or you do the query implicitly because you know that all the numbers to the left is going to be 0. So that means that you can you only have to pre-process the numbers that are smaller than 1 to the left. And I think that is the way to do it, right? Kind of a crazy problem, but I think now I want to believe in it. So yeah, hopefully that makes sense so far. Because a lot of this is free flowing because I am trying to solve it live. I'm not like, you know, yeah, but I think I like to remap it and then just go through the other array. And that would be a little bit better. Yeah, so here maybe we have for index x in enumerate num sub 1, and then we just mapping of x is equal to index, I think. Yeah, right. Actually, it could be an array because we use all the things anyway. Yeah, right. And then now, so now we know that we basically mapped everything from 0 to n, right? So then we have to remap the second array as well. So maybe new or map nums2 is equal to right? So for x in nums2, we just map it to mapping of x, right? And maybe I'll just print it out really quick just to make sure that I'm on the right. And because with these mappings, sometimes it's very easy to I'm not gonna wrong one. It's easy to kind of like do the reverse mapping by accident, and this is kind of what we did manually, right? So that's good. So this is what we want, and then now we just have to go through for x in num sub 2, right? Here now 0 we go, okay, well, how many numbers we've seen that are smaller so far, right? So we can kind of do that, and here we kind of could kind of keep track of everything in a sweep line kind of way, right? Because here in the beginning, all the numbers are going to be bigger, so maybe you could write like bigger to the right is equal to, I don't know, n maybe, and then smaller left is going to be 0, right? And then now when you process x, okay, let me think about this. I mean, we're almost there, I think, but we have to be a little bit careful, that's all. So we have this array, right? So then, oops, we start with the number 0. Then we know that all the numbers are to the right, so maybe this should be n-1, maybe. I don't know, wasn't sure, right? And then smaller numbers to the left, right? So then 2. Can I do a sweep or do I have to do a query? Maybe I have to do a query. Right? Yeah, I mean, I think that's fine. All right, let's just do it that way. I think I was trying to be too clever, and maybe you can be too clever or do it in a clever way. But for now, let's try to get it correct first, and then we'll maybe upsolve it later if we have to, right? So maybe seen is something to the left, and here we'll just have a sorted list because we want to. Yeah, because we want to maintain a list that is sorted. We want to maintain a list that's sorted and also count the number of things that are smaller than x, right? In other languages, you can probably do something similar. So here at the end, we add x. Otherwise, we just do smaller left is equal to, okay, so left is going to be equal to the things you've seen, right? So everything in seen is going to be left, and you can actually just increment this. And then smaller left is going to be equal to, yeah, this is where we use it to binary search, right? Binary, well, I was trying to think whether binary, we want bisect left or bisect right, but it doesn't matter in this particular problem because all the numbers are unique, so you should not be binary searching. Like, it should not matter because the number's not in it. So yeah, so that is the number of smaller x, right? So then now, yeah, right? And then now on the right side, how many is bigger right, right? Well, I think we could just do the math. Right is equal to n minus 1 for itself minus left, right? So then bigger right, so how many numbers are bigger, right? So bigger numbers is equal to, if this is, maybe I should have added an index, even though the index is also left, right? Because number of numbers that are bigger should be just left plus 1, right? Because on your left side, the numbers that you've seen, the count of them is the numbers that are to the left. So then the numbers that are to the right, actually, I guess bigger is also just equal to right then in that case, right? And then we want bigger to the right is equal to all the bigger numbers minus bigger to the left, right? Because yeah, this is the whole set of all the bigger numbers, and these are the numbers that are bigger on the left, right? And of course, we have to do bigger left then, right? Then bigger left is just equal to left minus smaller left, right? So there you go, right? It's very confusing, kind of, but you can kind of reason it. I know that you can probably simplify this, but I want to leave it out just for the thing. And then now we have the two things that we want, which is how many numbers are smaller to the left and how many numbers are bigger to the right. And then we can just multiply them to get the combination, right? And this part, hopefully I don't have to explain too much, but if you have like 2 things you can choose on the left, 3 things you can choose on the right, and that gives you 6 things, for example, right? And that should be it. Ideally, I feel like I say that a lot and then I'm like, oh, nope, you misread the problem or there's something silly. Okay. Okay, not as good as I would like, but that's fine maybe, right? So why do I have 2? Let's see. Let me double check. 0, 1, 2, 3 maps to 1, 2, 0, 3, right? So the 1 does nothing because yeah, it has nothing to the left. So the 2 has 1 smaller number to the left, right? Yep, we added. Okay. Yeah, 1 smaller number to the left, and 1 bigger number to the right. So that should be 1. Okay. 0 has no numbers to the left. Oh no, yeah, no small numbers to the left, so it doesn't do anything. So that's wrong, or like it's not going as I would think it would. So let's debug that a little bit. It may be just that like I have an off by 1 somewhere, which is fine. And of course, if you see a -1, that's a big smell, right? Bigger. The n should be right. Okay. Okay, so for number 1, 3 numbers that are bigger to the right is wrong, right? Because for we have this array, you know, only 2 of them. So I guess my bigger right is wrong. So bigger. Okay, so how many numbers are bigger? Left. Oh no, how many numbers are bigger to the right? Right. So here it should be 4 minus 1 minus. I guess this is the first number, so this is 0. So this should be 3. So this is 3. None of them. None of the 3 numbers that are. Wait. No, this is 1, right? So if this is 1, then this is off by 1 somehow. Because obviously there are no 3 numbers to the. Oh wait, no, the right is right, but the bigger is wrong. Why is the bigger wrong? No, the bigger is wrong. Okay, because I think this is why you also don't want to simplify to begin too early, right? So okay, this is the number of numbers to the right, which is right, but then the numbers that are bigger in total, it's actually x, right? It is depending on x. So I kind of messed this up here. So the total number of numbers bigger than x is just n minus 1 minus x. Because I was trying to, I don't know what I'm thinking of. Because if this number is 1, then yeah, you don't have 1 or 0. Right, so you have 2, yeah. Okay. So a little bit of a, that's why you kind of leave it on like this, even if you could have simplified because you may be wrong. And I did, yeah, I mean, I printed that to prove the point, of course. But yeah, let's give it a quick submit. And yeah, it looks pretty good. Yeah, I mean, I think this is a very tricky problem. yeah, I did not know how to do this beforehand. I mean, I've done it before apparently, but I don't even know when. Let's see. I mean, that was like 3 years ago. Jeebus. And apparently I got it wrong last time, but this time not so much. Oh, I did it with, I mean, I think it looks like the idea is roughly the same because I just used, yeah, I mean, I keep track of bigger and smaller in a different way, but today I did not do it that way. But that's the thing with these data structures, right? Is that they're there because it allows you to answer questions about bigger and smaller, and that's probably what I end up doing with this. Which I also did here, right? So I don't know, it's a little bit cleaner, I think. But yeah, did I do mapping there? No, I just straight up did. Oh no, I did do a lookup thing, and then I remap number one. Oh, I see. I remapped the nums2 to map 1. So I actually did the same thing when reverse. And instead of doing all this math to calculate how many numbers are bigger or smaller, I used whatchamacallit, a binary index tree. But yeah, but that said, it's still the same complexity. The reason being that you're still dominated by this binary search, right? This is O of n, this is log n, so it's going to still be n log n, no matter how you do it. Not no matter. There may be a way to do it, but definitely we did not do it that way. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching. Hope we kind of got through it. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.